Hey, so I know it's been a while, but I've been busy with a lot of stuff, and well, finally, relatively have some free time to work on some more videos now. But decide not to focus on anything pertaining to specifically CSEC maths or odd maths. I just want to do just maths and physics now. Later down the line, I will talk about them then coming closer to exam time for the students who will be writing exams, but I just want to have some fun in these videos because since the last upload, a lot of ideas has been stewing in my mind. So first thing I wanted to talk about is coordinate transforms. Coordinate transformations. Well, as you all know, my handwriting is not the prettiest, but the essence of the math is here. Coordinate transforms, coordinate transformation. So most students who doing math or physics or any of the sciences, I'm pretty sure they are familiar with the Cartesian plane, that is the x and y axis. And recall, this is a two-dimensional coordinate system, meaning you could move to the right, you can move to the left, you can move up, and you can move down. Two dimensions, like this way and that way. So in the Cartesian plane, like any point, well, point P, you need a x and a y value to represent that point, meaning some number on the x-axis corresponds to what you go some unit to some value to the on the x-axis, be it to the right or to the left, because the point could be here too. But for simplicity, let's just keep it in the positive side for now. And well, we need some value up in y. So it's kind of like you're going in x and then up in y. So and the convention is like to draw like a dotted line to connect the point to show okay. Like so for each point on the Cartesian plane or the x and y axis, there's a corresponding x value and there's a corresponding y value. No, there's a more interesting two-dimensional coordinate system. Let's say for the same point now, we consider a line starting from the origin O or 0, 0. And this line, let's denote this with some r, meaning there's some radius. Because the coordinate system we going to talk about is called the polar coordinate system. Polar, and loosely stated, deals with circles. So consider some line, some distance r from the origin, and it makes some angle measured from the x-axis in a counterclockwise direction, theta. This is normal trigonometric knowledge here. Now, from Pythagoras' theorem, we should know that this x value given in terms of theta is cosine theta, and this y value is r sine theta. So the magnitude of that line r, or the length of that line r, is given by r squared sine squared theta plus r squared cos squared theta. And well, if we just look at over here, we could deduce that the magnitude is just the square root of x squared plus y squared. This comes from the Pythagorean theorem. I mean, I didn't need to do this, but why not? So for any point on the Cartesian plane, we could describe it in terms of a line of a radius given by this, and the angle is tan inverse of y on x. This again comes from traits. This comes from traits. So let's look at this with an example. So let's say we had the point 4 and 3. Now transform this into polar coordinates. We could describe this as a radius, or a line starting from the origin with a magnitude of 4 squared plus 3 squared, which is root 16 plus 9, which is root 25, which is just 5. So the line, or the vector, it's a vector, the line, for simplicity's sake, has a length of 5 units, and the angle is the tan inverse of y on x, and the tan inverse of y on x is 0.64 radians. Now we can work this in degrees, but I like to put it in radians. So in polar coordinates, this thing here, this Cartesian, it becomes this. So you have the R, and it will make an angle like that, 0.64 radians, and a unit, a length of 5. This is the transformation from Cartesian to polar, because we transform this point in terms of a r and a theta. Here it was in terms of a x and a y. Now I kept this in this particular region of the Cartesian plane because when it goes to the other regions, like it has some more trigonometry behind it. But this is a simple example of a coordinate transform. Well, a two-dimensional coordinate transform. So a point in terms of x and y. So a point in terms of x and y becomes a point, well, not a point, it becomes vector a vector in terms of r and theta. Coordinate transform. There's other coordinate transform I will talk about in future videos, but for now, simple two-dimensional coordinate transform.